Hello everyone and welcome back to these sessions on quantitative methods for CFA Level 1. As you can see, we are talking about the topic estimation and inference. That is chapter number 7. So we have already landed into the inferential statistics. So what do we mean by inferential statistics? Let me explain it to you. In fact, I've already given you a glimpse of this when we were talking about simulation methods in the earlier classes. What is inferential statistics and what is the meaning of the word inference? Estimation, I don't have to explain you know what is estimation. So it is like this. You want to understand some characteristic of a population. For example, you want to know average income of individuals in a particular town. Now, the town has say 3 million residents and maybe half of them are working. It is still a big count. So, you cannot inquire about the income of all those 3 million people or 1.5 million people. You cannot do that because it is too large population to analyze. So what you want to do, you want to take samples from that particular population. So population in this case is the count of the working people in that town, the total count of the working people in that town. That's the population, which is 1.5 million people. Difficult to take statistics from each and every one. So what we do, we resort to sampling techniques. That is what we have learned even in the previous class. What is sampling theory, correct? I'm not going to discuss all this thing in this particular class because we have already talked about that. What I'm just trying to convey is, because some students ask me doubt that sir, we are not clear with this title inference. Let me explain it to you. So from that population, you have drawn samples and now you are making the estimation of the population average income level by analyzing the samples. So you are taking the data, you are gathering the data from the samples that you are studying, but you are drawing estimation and inference about the population. In other words, suppose you have collected sample of 1000 individuals at a time and you have taken 5 such samples. So you have taken samples of 1000, 1000, 1000, 1000, 1000, 5 samples, and randomly you have picked up these samples. So what you are going to assess from this is the average income level of all these individuals in the samples that you have collected, which basically is the sample mean. But you want the average income level, the mean income level of all those 1.5 million people in that town which are working, correct? So you are not going to make the actual computation, you are going to make an estimate of what would be the mean income of that big population, where your study is basically 5 samples of 1000 individuals each. So you are analyzing the data that you have gathered from these 5 samples. Based on that, you are making estimations about what would be the average income level of all the working people in that town. And once you have made an estimation, you are trying to inference. That means you are trying to relate that whatever I am observing in this sample, the sample is resembling the same population, correct? This attribute of sampling, that when you believe that the sample is resembling the population, that is what we call as inference. You are drawing the conclusion about the population without studying the population itself. You are studying a sample and drawing conclusion about the population. So if you want to highlight the meaning of this word, inference, I'll write it for you. Let me put myself away from the screen. The meaning of the word inference, if you want to know. Studying few samples and drawing conclusions about the population. You are studying samples but drawing the conclusion about population. That is the meaning of the word inference. I'm sure you're clear with the meaning of the word inference, and along with me you would have written the same as well. So now, if you have understood what is estimation and inference, that is the main title. In the previous class we already started with sampling theory. What is sampling theory? Sampling theory is the field of statistics that studies how to select a subset, that is sample, from a larger set, that is population, to make inferences about the population. We already learned this term, right? To make inferences about the population. The goal is to draw conclusion about the entire population without having to study every member. That is what I have written in this part, the meaning of the word inference. So I believe you all are clear with the meaning of the word inference, correct? And you are ready to take the discussion ahead. So what is sampling theory? What are the key concepts in sampling theory? Population, sample, sampling frame, sampling error, and then sampling is crucial in statistics for several reasons. Then we have gone through all these reasons. I've already talked about all these things. I don't want to repeat that. One of the very, very important aspect of sampling is used for hypothesis testing, and that is going to be your next follow-up topic. Now this chapter, estimation and inference itself, is a big chapter. Here we have started learning the basis of sampling theory, and then we are drawing conclusions from the sampling theory. Gradually we will move on to sampling distributions. We will also learn the law of large numbers. Then through sampling distribution we will learn standard error and the central limit theorem, and some techniques like bootstrap and jackknife, which are used for drawing inferences. So it's a big topic, that is why I have divided that into parts. So by far whatever I have discussed in this class today, that is all about the revision of what we have done in the previous class. It is this part that I am mainly focused on, techniques of sampling. So sampling techniques can be divided into two major segments. One is the probability sampling and another is non-probability sampling. So what is sampling we have learned. So we are now trying to understand techniques of sampling, or different ways of sampling, different types of sampling. How can you carry out this sampling process? Broadly divided into two categories, that is the probability sampling and non-probability sampling. What I would want you all to do, though these notes are there with you, but this segment I want you to note it down, which indicates all the techniques of sampling. I want you to write it down in your notebooks. Alright friends, I am sure you would have completed writing this whole thing. So now uh, let us get back to what we were discussing as techniques of sampling. We are first going to talk about probability sampling. Probability sampling is a sampling technique where each member of the population has a known non-zero chance of being selected. Now, you understand it as simple as this way. You have, say, a kind of selection made by a lottery system. Say there are 500 members in an educational institution and you want to select only 20 out of that. So you have asked each member to write their names on a small piece of paper, folding that as a chit, and you have placed it in a big box. You are shuffling the whole box and now drawing lottery system. That means you are following a lottery system. You are drawing names out of that big box. You want to select 20, but there are in total 500 names included in that box. Each of the name has equal chance of being drawn, correct? There is no specific criteria to select or not to select anyone. Equal chance of each one being picked. This is basically probability sampling, where each one has equal probability of being picked up. Now, non-probability sampling would obviously not follow this. So if I take you to the detail of what is exactly probability sampling, let me read the content further for you. This method ensures that sample represents the population and allows for calculation of sampling error. That line basically means, see, you are aware that population is not homogeneous, population is heterogeneous. Even though you have given equal chance for all the items to be selected, but still the random selection that you have made from the lot may still have some sampling error, because the attributes of that sample may not reflect the attributes of population in true sense. So there may be sampling errors, we do not deny. So we do have possibility of sampling error even though if it is probability sampling. It refers to selecting a sample when we know the probability of each sample member in the overall population. With random sampling, each item is assumed to have the same probability of being selected. On the other side, what is non-probability sampling? These techniques involves selecting samples based on subjective judgment rather than random selection. In these methods, not all members of the population have known or equal chance of being included in the sample. So you broadly understand that when there is a criteria of selection applied, you will put it in which category? Non-probability sampling. Where there is no specific criteria, you are just applying the random sampling. There, the chance of a sample being picked or an item being selected in a sample is having equal probability of all other items, then it is basically coming under probability sampling. If this characteristic is not fulfilled, it is non-probability sampling. This is how the broad categories you make for probability and non-probability sampling. But our focus point will be to understand each of these sampling techniques. Starting, and I'm sure you have already written this whole thing. So we start with simple random sampling. Now, when I was explaining you what exactly is probability sampling, simple random sampling is the most effective part or most effective way of probability sampling, simple random sampling. So as I gave you that example of picking 20 names out of those 500 names, it is simple random sampling because you are simply making a random selection. So let us read about this simple random sampling first of all. Simple random sampling is a fundamental sampling method where each member of the population has an equal and independent chance of being selected. This technique ensures that every possible sample of a given size has the same probability of being chosen. So what we learned under the probability sampling meaning, that same meaning is conveyed for simple random sampling. So what are the key characteristics? Equal probability, independence and random selection. These are the three key properties. So first thing, equal probability. Every member of the population has equal chance of being picked, that is equal probability. Independence, selection of one is independent of the other. That means anything can be picked up. Of course, how many items you are going to pick up, that is your decision about the sample size, but selection of one is not dependent on the other, it is independent. And random selection, there is no basis for selection, it is all randomly picked up. Process of simple random sampling. Let us understand the procedure. First, you define the population. Clearly identify the population from which the sample will be drawn. For example, all the students in a university. List the population. Create a complete list or sampling frame of all members of the population. For example, list of all enrolled students. Then number 3, assign numbers. Assign a unique number to each member of the population. For example, each student is assigned a number from 1 to 10,000. And finally, fourth step is random selection. Use a random number generator, random number table or another method to randomly select required sample size from the list. For example, use a random number generator to select 200 students from the list of 10,000. So basically, I don't have to explain you again what are random numbers, because in simulation methods we have already learned what are random numbers and how random numbers can be generated, correct? Random numbers are generally generated out of computer system. So you can just ask a computer system to generate a series of random numbers for you and it will do that. Where the numbers are truly random, that means the chance of occurrence of each number in that sequence is independent and equally probable. That is why let the computer system or any kind of random number generator play its role to generate random numbers and accordingly you make selection. In simple words, where did we learn this application? We have learned this application in simulation methods, right? When we applied Monte Carlo simulation, there was application of random numbers for carrying out simulation runs. So you know what exactly is the role of random number over here. So now let me take your attention to the next sampling technique, that is systematic sampling. In this technique, what is mentioned, every nth member of the population is selected after a random starting point. This method is straightforward and often used when a complete list of population is available. For example, selecting every 10th person from a list after starting from a randomly chosen position. So, in that lottery based system where we are simply picking a number, instead of that you arrange all the population members, correct? And when you have to draw a sample, say after randomly arranging, the arrangement has to be random. After randomly arranging the whole population, you are drawing a specific interval, that means every 10th member. So you have selected, say, starting point as 5th member, then the interval should be 10 members. So after 5th member being selected as one item in the sample, you leave the interval of 10, then you select 15th member, then again skip 10 and select 25th member, again skip 10 and select 35th member. That means you are keeping a constant interval. So you are applying randomness in the whole spread where you have arranged the whole population randomly, but now selection what you are making is not anywhere from any lot as random, it is systematic. So you are picking certain intervals and starting with a certain point. That is what we call as systematic sampling. So let us observe the process of systematic sampling. Step 1. Start with the complete list of population you want to sample. Step 2. Decide how many samples you need from the population. Step 3. The sampling interval k is calculated by dividing the total population size by the desired sample size. For example, if you have a population of 1000 and you need a sample size of 100, your interval k would be 10. Now interval k is dependent on these two facts. What is the population size and what you want as your sample size. So in this example what we just read given over here, if the population size is 1000 and you want to draw a sample of 100, that means your selection is going to be 1 out of 10. So your interval will be 10. That means when I give you that example, 5th member, then 15th member, then 25th member, then 35th member and so on, the gap is 10, 10, 10. That interval is constant. That interval depends on the population size as well as the sample size. Suppose I want to draw not a sample of 100 out of 1000, but I want to draw a sample of 200 out of 1000. Then 200 by 5 is 1 by 5, or I would say if you inverse that, it will be 1000 by 200, that is 5. Interval becomes 5. When interval becomes 5, every 5th member is going to be selected. Now you define a starting point, say second member. You selected second member. Now after second member, every 5th member. So 5th count from second, if I have 3rd, 4th, 5th, 6th, 7th. So I will select the 7th member, then the 12th member, then the 17th member and so on. So my interval got little narrow because the sample size was bigger. On the contrary, if I reduce the sample size to 50, then 1000 in the population divided by 50 in sample, my interval would be 20. Correct? 1000 by 50 will give you 20. So every 20th member will be then selected. So that is basically the entire procedure over here up to 3rd step. Then step 4, randomly choose a starting point between 1 and k. If k is 10, you might randomly pick the 4th member to start. After starting point is selected, you pick every kth member from the list. For instance, your starting point is 4 and your interval k is 10. You would select 4th, 14th, 24th members and so on until you reach the sample size. So that is all about systematic sampling and the process of systematic sampling. Now moving further, we have the third one as stratified sampling. Stratified sampling involves dividing the population into distinct subgroups or strata that share similar characteristics and then randomly selecting samples from each stratum So basically stratum is the singular and strata is the plural. So the strata are internally homogeneous, meaning members within each subgroup are similar in terms of certain characteristics, for example age, income level, etc. Random samples are taken from each stratum, ensures that all subgroups are represented in the sample. So let me give an example to you. Suppose a big engineering college that is offering 5 streams: civil engineering, chemical engineering, mechanical engineering, electric engineering and computer engineering. 5 streams of engineering, and you want to make the sample selection out of the entire college students. So what you do? First you divide the data, the whole population, into 5 strata. So each stream is representing a stratum. If each stream of engineering is representing a stratum, within the stratum, the members appear to be homogeneous because they have similar characteristics. Then you randomly draw something from mechanical engineering, randomly draw something from electrical engineering, something from computer engineering, something from chemical engineering, something from civil engineering. You draw random samples. That means this technique will ensure what? That from all the streams you are doing this. Let me take this to your level of example or your type of example. For example, I want to create or construct a stock market index. Now there are various sectors in the stock market, right? There will be iron and steel, there will be mining, banking, insurance. I want to make sure that the index is constructed out of every sector. So what I'll do? First, I will divide the whole group of available companies listed in the stock market as into different stratums. That is, each company following its particular line of industry or its sector. Then I may make either a random or a selected or judgmental sampling from within the frame. So it may not be giving you perfect example of stratified sampling, because for construction of index your sampling or your selection may not be random, it could be little systematic or judgmental as well. So you want to take only the top performing companies. It comes under non-probability, that is judgmental sampling, because you are taking only the high profit companies, or you are picking the companies which are having high market capitalization. So you have a particular criteria of selection, that is selective sampling, and it is not random sampling. So index is constructed out of selective sampling and not random sampling. But when you construct the index, you would want to ensure that you are touching every sector in the economy, that each sector is representing a stratum, and there stratification is involved. So stratified sampling is all about that. So let me read out the whole thing for you along with examples. So this line once again: the strata are internally homogeneous, meaning the members within the subgroup are similar in terms of their characteristics. Random samples are taken from each stratum. Now this particular line, random samples are taken from each stratum. Earlier I gave you example from that engineering college. Later on I gave you example for creating a stock market index, but stock market index example may not fit 100% into this, because over there this randomness will be missing, correct? Now this ensures that all subgroups are represented in the sample. Example, if a population consists of students from different grades, you would divide the population into strata based on grade levels, for example first grade, second grade, similar to that engineering example, and then randomly select students from each grade, randomly select students from each grade or each category. That could be actually the stratified sampling, or in more technical terms you can call it stratified random sampling. Stratified sampling uses a classification system to separate the population into smaller groups based on one or more distinguishing characteristics. From each subgroup or stratum, a random sample is taken and the results are pooled. The size of sample from each stratum is based on the size of the stratum relative to the population. So simple logic is, if the stratum size is big, the sample that you pull out from that stratum should also be little big. If the stratum is small, then the sample that you pull out from that also should be a smaller. You are going to again pull up all your samples together. So ultimately you will create a mixed bag. Your objective was to bring the characteristic from each stratum. So that was stratified sampling, and more description given over here which you can read and follow up. There is nothing more from my side to be explained over there. I will rather focus on the next sampling technique, that is cluster sampling. So let me first talk about cluster sampling, and then I will go into the details of what could be the difference between the stratified sampling and cluster sampling. In all the batches, students generally ask me, sir, how would you distinguish between the two? So I know that this is going to be a doubt in your mind, and therefore I am going to clarify from my side itself. But let us first focus on what is this cluster sampling. Cluster sampling involves dividing the population into clusters which are usually naturally occurring groups. One big difference, these are naturally occurring groups. When I say naturally occurring groups, what do we mean by naturally occurring groups? See, in stratified sampling, what did you do? You designed the strata based on their characteristic. On the other side, the cluster is not something that you are having any particular criteria. For example, I take one particular city, and that particular city I divide into small clusters. Within the city there may be, say, 30 different areas. So there is a big city having 30 different areas, correct? Each area represents a cluster. So that area is geographically defined. You did not put your criteria over there. So that is not a stratum, it is a cluster. So suppose the entire city is numbered into sectors, sector 1, sector 2, sector 3, sector 4, and likewise there are 30 sectors within a city which are based on geographical location. Now here there is no specific criteria that you are applying. Sector 1, when you say sector 1, universally everyone will know what is sector 1 because it is designated geographical location for people residing or working in that sector, in that town. Sector 1, sector 2, sector 3. So these sectors are not stratums, these are clusters. So let me read it out further for you. So the cluster sampling involves dividing the population into clusters which are usually naturally occurring groups, randomly selecting some of the clusters and then including all the members of the selected clusters in the sample. Now you see, This is itself one major point of difference between stratified sampling and cluster sampling. See, what did you do? In stratified sampling, you have made different sectors by your own criteria, and then you are picking randomly from all the strata. From each stratum you are picking a sample or picking few items to be included in the sample. Under cluster sampling, clusters are not designed by you, they are already existing. You are not picking randomly the numbers from each cluster. You are in fact deciding that which clusters you want to select. So you decided that there are 30 sectors. I would want to select sector 2, sector 17 and sector 25. That's all. Now from where did I get this 2, 17 and 25 as numbers? Even I don't know. I randomly uttered. So the random selection of cluster is then made, but when you select a cluster, then the whole population within that cluster you have to study. So that is cluster sampling. In stratified sampling, you are not leaving a single stratum, you are picking samples from each, but selecting limited number of people from the whole strata or from the whole stratum. On the other side, when it is cluster sampling, you are not picking all the clusters, you are picking only few clusters, but whichever cluster you are picking, that whole thing you are picking together. That means the entire population. For example, the population in the town is say 3 million people divided into 30 sectors. So if I simply say 3 million people divided into 30 sectors, each sector say has an average population of 100,000 people, correct? That would do the math. 100,000 people. 100,000 people in each cluster. Now, as I said, I am selecting sector 2, 17 and 25. That means 100,000, 100,000, 100,000. These 300,000 people I will be selecting out of 3 million people in the town. So basically my sample size is 1/10 of the population, but that sample size itself is a huge compared, because the population was quite big. But do you notice what I am doing? I am not picking samples from all 30 clusters. I am selecting only 3 clusters randomly. But when I select 3 clusters randomly, each 100,000 people in each cluster, I mean in each of those 3 clusters, will be considered in sample. That is cluster sampling. So let me take you ahead with this discussion. Just a moment. Clusters are internally heterogeneous. Look at again a difference. In case of stratified sampling, the strata are internally homogeneous, whereas what we observed over here, in case of cluster sampling, clusters are internally heterogeneous. This is one difference again between the cluster sampling and stratified sampling, meaning each cluster is a mini representation of the population. Entire clusters are randomly selected. All individuals within the chosen cluster are sampled. Now moving ahead. Example, if you want to survey households in a city, you could divide the city into clusters based on geographical areas like blocks or neighborhoods. You then randomly select certain blocks and survey every household within those blocks. So cluster sampling is also based on subsets of population, but in this case we are assuming that each subset or cluster is representative of the overall population with respect to the item we are sampling. For example, we may have data on incomes for states residents by county. The data for each county is a cluster. In one stage, cluster sampling, a random sample of clusters is selected and all the data in those clusters comprise the sample. In two-stage cluster sampling, random samples from each of the selected clusters comprise the sample. Contrast with the stratified random sampling, in which random samples are selected from every subgroup to the extent that subgroups do not have the same distribution as the entire population of the characteristics we are interested in. Cluster sampling, we will have greater sampling error than simple random sampling. Two-stage cluster sampling can be expected to have greater sampling error than one-stage cluster sampling. Lower cost and less time required to assemble samples are primary advantages of cluster sampling, and it may be most appropriate for smaller pilot study. Now, next thing that we need to discuss is about non-probability sampling methods. Number one in this category comes as convenience sampling. So, convenience sampling. What is available in front of you, you just analyze that data and consider that it represents the whole population. Suppose you want to take some views of some people in a particular town. You reached that town, you landed at the airport, and once you came out of the airport, for some reason you are not able to move out from there immediately. What you did, you started the inquiry then and there itself. That is, at the airport you started your sampling process. You started inquiring people about whatever you want to know. Why? It is the most convenient, because you have time and you would want to spend that time on what is available near around you. So you don't want to miss that opportunity. This is what we call as convenience sampling. So convenience sampling has this kind of characteristic. So let me just explain it further to you. So once again, convenience sampling is a type of non-probability sampling where the sample is taken from a group that is easy to access or contact. It is one of the simplest forms of sampling and is often used when quick and easy data collection is required. However, it is also one of the most criticized methods because of its high potential for bias. Let us take an example to understand this point. Imagine a researcher wants to study the eating habits of college students. To quickly gather data, they distribute surveys to students sitting in the campus cafeteria at lunchtime. So if you look into that, they are approaching to the campus cafeteria during lunchtime, and you find that people who are having their lunch, they will be available over there, and it will be convenient to ask their opinions and feedback, etc. So if you have this kind of approach, you are looking for convenience in sampling. So that is why it comes under convenience sampling. Reading further, in that example, what was the population? All college students. Sample, students in the cafeteria at a specific time. What was the convenience involved? The researcher chose this group because they are easily accessible at that moment. So convenience sampling refers to selecting sample data based on its ease of access using data that are readily available. Because such a sample is typically not random, sampling error will be greater. It is most appropriate for an initial look at the data prior to adopting a sampling method with less sampling error. Now that was about convenience sampling. Let us move on to the next aspect, that is judgmental sampling. Judgmental sampling is a non-probability sampling technique where the researcher uses their knowledge, expertise and judgment to select participants that they believe are most representative or useful for the study. The selection is based on specific criteria relevant to the research question rather than random sampling. So here basically you want to apply your judgment as to from where you should pick the sample. So your sampling frame comes into picture and you are typically focusing on that frame only. So instead of a random selection, you are having a qualitative selection or a criteria based selection. So this is definitely not coming under probability sampling. Selection criteria is available. Lot of examples you can take over here. Lot of examples. For example, I would want to know the behaviors of human resource managers in different companies. So what I'll do, I would want to just pick a few employees from HR department to assess the management skills of the human resource department and maybe selecting a sample of the core employees to look into what is their opinion about the HR management, correct? But my focus point will be the HR managers and their teams. So I have a select set of criteria where I would want to pick my sample from, and I'll pick my samples only from there. You can take a lot of examples. Suppose I want to observe that students who have not done good in quantitative methods in CFA Level 1 exam, I would want to just interview these students. It is a judgmental sampling. Or my students who have done excellent in topics like fixed income and derivatives, I would want to take a view from them as in what review they would give about my training and how they find it overall. In that case, when I am picking a sample, I am having a judgment or a criteria applied over there. So what is the drawback do you see in this? There is a bias involved, right? There is a bias involved, some kind of bias. It may be favorable, unfavorable, but there is a bias involved. You are having a judgment applied on selecting your samples. It is definitely no random sampling. It is what we call as judgmental sampling. So let us read about this. Judgmental sampling is a non-probability sampling technique where the researcher uses their knowledge, expertise and judgment to select participants that they believe are most representative or useful for the study. The selection is based on the specific criteria relevant to the research question rather than random sampling. Further given, the researcher decides which participant to include based on their expertise and specific needs of the study. I would want to underline this particular point. The specific needs of the study. So researcher decides which participants to include based on their expertise and the specific needs of the study. Further given, participants are chosen because they possess characteristics, knowledge or expertise that is particularly relevant to the research topic. The criteria for selecting participants are predetermined and aligned with the research objectives. For example, a study on expert opinions might only include industry leaders or subject matter experts. The goal is to gather in-depth information from a specific group rather than to generalize findings to the entire population. The sample is often small but rich in information needed to address the research question. So basically, the outcome of this judgmental sampling, sample size will be small because you have a selective criteria of what to be included in your sample, but it will be highly informative because you are doing only and only the relevant selection based on your specific criteria. So there is bias involved, sample size will be generally smaller, but it will give you a big set of information. What you want to extract, you will get a quicker and more relevant information about the subject matter what you are sampling for. Then later things you can definitely read out on your own for your further understanding. Then comes quota sampling. Quota sampling is a non-probability sampling technique where the population is divided into distinct subgroups or quotas based on specific characteristics. The researcher then selects a predetermined number of participants, that is quota, from each subgroup. The selection within each subgroup is not random but is instead based on convenience or judgment. That means here you are using partially the aspects of convenience and judgment sampling, but you are putting it to a certain limit which we can call as quota. The population is first divided into mutually exclusive subgroups, also known as strata, based on certain characteristics like age, gender, income level, education, etc. These characteristics should be relevant to the research question and the study objectives. So, stratified sampling and this quota sampling may have one similarity, that the whole population is divided into strata. But in stratified sampling, after dividing the population into the subgroups called strata, then the selection made from within the strata is random. Here you are not applying random selection. That means when it is stratified sampling, but from within a stratum, when you are picking not randomly but using convenience or judgmental sampling, it becomes more or less a quota sampling. So what is the use of the word quota in this particular sampling? Now, one most relevant thing that I would generally want to do in my analysis, do you know, when I go for observing the viewers in my YouTube channel, most of my viewers are students. That too, a specific category of students, CA students, CFA students, CMA students. Most of my videos will be viewed by students in India because CA students, CMA students will be generally Indian students. So, I have a certain age group, I have a certain parameter that I would want to make sample. If I want to know what my students want me to give them further in terms of what kind of concepts they want me to shoot videos on, I want to take a view. So for that I will obviously take students view. So I may put up a question on my channel itself and observe who is responding to that and accordingly to which strata the student belongs, and based on that I get to know what is generally demanded by my viewers for my next few videos on my channel. To get this idea, I am using this kind of quota sampling. So again, coming back to the term quota, for example, I do have candidates and students who are under 20 years age, that is from the age range of maybe 17 to 20. People who have just completed graduation and started learning finance. But majority of my students will be falling in the age group of 20 to 25. Then some senior people who would be falling in the age band of 25 to 30, and some selected or some small group which falls between the age category from 30 to 35 or 35 to 40 as well. What happens? I have multiple age groups as my viewers, and the most relevant age group that I have is between 20 to 25 years of age. Most relevant age group for my viewers. What I will try to do? Tell me. I will try to take a bigger sample from this category and maybe smaller samples from other category. So I am fixing that from 15 to 20 age group, I want only so many candidates. From 30 to 35, only so many. From 35 to 40, only so many. Between 25 to 30, it will be a substantial size, and the biggest size will be from 20 to 25. That shows that I am applying quota sampling, where for selection within the strata, it could be either judgmental or convenience sampling that may get involved. So that is all about quota sampling. Now, if we can take an example over here, like say, for example, if the population consists of 60% males and 40% females, the researcher might set quotas to ensure that sample reflects this distribution. Within each subgroup, participants are selected based on convenience, availability or judgment rather than using random sampling techniques. This is the most important characteristic of quota sampling. This means that while the overall structure of the sample reflects the population, the individual within the quota are not randomly chosen. Now, the last in this category would be what we call as snowball sampling. Now, what exactly is snowball sampling? Do you know what is the nature of a snowball? It starts with a very small, tiny snowball. As it rolls down the hill, it keeps accumulating more and more snow along with that, and the ball becomes bigger and bigger. By the time it hits the ground, it's huge ball of snow. Correct? So, what happens? When you select a very small group of people, very small group of people, and then you ask them that who else can be included. You include some more people, then ask them who else can be included. You know, it's a kind of chain pulling, chain reaction. You are including more and more in the sample through the references of the items selected in the sample. So you select a few items, then inquire through those items which more items can be included. This is done when typically it is difficult to identify the relevant crowd. For example, I would want to know from India how many students are pursuing the Cambridge University Master of Finance course. Now, this is going to be very rare number, correct, within this big country. How will I come to know? So, what happens? I get one student from this particular Cambridge University and who is an Indian. Then I ask that student, do you know any more Indians who are into Cambridge University doing the same course along with you? Then that student tells me that yes sir, there are 4 more students along with me who are from different places in India. I asked that student that can you give me reference and contact details of these people? She passes on the contact details, and then I am in touch with those 4 additional students. Then I ask them that do you know some students who are willing to join Cambridge University Master of Finance course? And gradually I get to know what could be the relevant size of my sample that I want to study. Now, do you understand what is happening? Starting from one small unit in the sample and gradually asking or taking references from that one item in the sample and gathering more and more units to be included in the sample. This is what we call as snowball sampling. Now, with that discussion, which is putting an end to this whole discussion about snowball sampling, will be the last category, and with this the techniques of sampling or types of sampling, it's like done. So, when we are referring to any particular type of sampling, my advice to you is first always apply your understanding whether it is a probability sampling technique or a non-probability sampling technique, and then go within the details of the same. So, that's all for this particular class. Thank you very much for attending the class.